Hi everyone, this is Carlos with the EMX Science Support Team. Today we are looking at TULIPS, a tool for understanding the lives, interiors, and physics of stars. To get started, we are going to click on this About button. That will take us to this documentation page. Here we can scroll down and we can click on Installation to see how to install this. It's a simple pip install. In addition, we will also need MESA plot and TextLive for the animations we will attempt to create in the notebook. Now if we go back, you can go to Getting Started and it will run you through a simple tutorial. I took the liberty to put that tutorial over here in this Jupyter notebook and we will run through this together. So I've already pip installed this and I already have TextLive and MESAplot ready to go. You will also need to download this file, single_11msun/logs, and this file you can find it in Zenodo in this documentation. Now this file, or more so this folder, contains tons of data on stars, and what we're going to do is we're going to look for history.data, and what that will give us, that will be a file that contains the evolution of one-dimensional properties of the stellar model, such as its radius. Now, what we are going to try to do here in this notebook is look at the evolution of this star, given this downloadable file. So first thing that we can do is, let's say we want to know the star's age and the star's log radius. All we have to do is use this m11.hist.starAge or .logr, run that, and now you can see your array for your star age and your array for your star's radius in log space. Now, if you want to play with it a little, you can simply do m11.hist. and then press the tab key on your keyboard, and these are all of the options that it will give you, and we're not going to go through all of them because, as you can see, it's quite a bit. So yeah, pretty cool. Anyways, coming on down, so to create our first tulips diagram, we will need to import tulips, of course, and in this plot will be the perceived size and color of the star at some specific point in time. So we are going to use tulips.perceived_color. We're going to feed it our data, and then this is time index, so at some time, and of course the figure size. Now let's go ahead and see what that looks like. This is our plot. This is our little baby star at time 0.0 million years. So yes, very much a baby star. And over here, down here, you can see a Hertzsprung-Russell diagram. So here, the star is a brand new little baby, little blue baby. Now, if we want to look at the star as it grows in time, we can change the time index. And here you are. So now this is a much older star. Now we're looking at a red star, and it is 21.9 million years. Let's go ahead and turn that back to 0. Now, if say you want to look for some specific points, you can use this mp.where and then use this .center_h1 to look for some specific point in time. So for example, here we want to know at which point does hydrogen stop burning for this model star. And so what we're going to look for is where the central hydrogen mass fraction is very small, like here. We run that, we see that that's at 484. Let's change our time index to 484 just to see what that looks like for fun. Okay, so at this point, this star is starting to run out of hydrogen. Cool. Next thing we can do, now we can create our first tulips animation. So to create an animation, what you're going to do is you are going to use this tulips.perceived_color, and you will feed it this time index. So because this is an index, 0 to -1, that gives us all the data. Steps of 10 frames per second is 20, because we want a relatively slow movie so we can see what's going on. We can run that. We're going to wait for this to load. As you can see, it is creating our animation. We'll give that some time, and it will pop up a plot. Okay, now that that's all loaded up, now we can use this ipython.display import video module, and you're just going to use video, the name of the movie. Remember, you have to save it before you can create the movie, and then just run it. And now check this out. We can see our baby star go from a baby to an infant to a child to a teenager to an adult, if you want to call a 25 million year old star an adult. So yeah, this is Tulips, guys. Super simple tool, and really, really cool to be able to see the evolution of a star. And this can come in handy with all your exoplanet research, because different stars definitely are going to give us some sort of different planet. How? We don't know, but we'll find out soon. So that was Tulips. Really cool tool, very simple to use. If you have any questions, make sure to DM us on Twitter at Exoplanet Models, or simply comment below. Thank you. Peace.